In this video, I will show an example of a bad proof. A proof that contains errors that students often make when they begin to write proofs, and then I will explain how to fix those errors. The theorem I want to prove is this inequality, and I put theorem and proof in quotes for reasons that will become clear soon. In order to prove it, first I will get rid of the square root by squaring both sides. Next, I expand the square on the right-hand side. I multiply both sides by 4, and I subtract 4xy from both sides so that everything is on the right-hand side. And now I notice that here on the right-hand side I have a perfect square, and this squared is definitely non-negative, so this is true, and we are done. But are we? This proof is wrong from beginning to end, and in fact it is not a proof. The main problem is right at the beginning. I began by assuming what I wanted to prove. Effectively, I have shown that if this first inequality is true, then this number is non-negative. But that doesn't tell me whether the initial inequality is true or not. Probably the thinking here goes something like the following. This inequality is equivalent to this one, is equivalent to this one, and so on, equivalent to this one, and since the last one is true, then the first one must be true as well. But that is not what I wrote. I only work forward, and I never checked that every step was reversible. So once again, I have only shown that if this inequality is true, then this number is non-negative. But that doesn't tell me whether this inequality is true or not, which is what I care about. In general, it is forbidden to begin by assuming what I want to prove. I got it all backwards. I should start only with things I already know are true and end up concluding this inequality. In case this doesn't convince you, here is a second problem. What are x and y? The statement of a theorem is never just an inequality or an equation. A theorem may tell us when an inequality is true, or that it is always true, or that an equation has a solution, but this is just a plain inequality, nothing more. And this is not me being pedantic, because the inequality isn't always true. For example, look at what happens when x and y are both minus 1. The left-hand side could be the square root of 1, which is 1, and the right-hand side could be minus 2 over 2, which is minus 1. 1 less than or equal than minus 1. That would be false. So this inequality isn't always true. However, I never noticed it doing this so-called proof that I needed to restrict myself to positive numbers. If this were a correct proof, I should have noticed at some point that x and y need to be positive, or at least non-negative. The goal of a proof is to figure out whether a statement is true or not. And a proof that works equally well for something that is true and something that is false is not a proof. It is completely useless. And finally, this proof has no words, only algebra. Sometimes this may be okay, but in general, a proof is going to require explaining what we are doing. Let's fix this proof. First, let's write the statement of the theorem correctly. What the theorem should say is that if x and y are any non-negative real numbers, then this inequality is true. Now, how will the proof go? Remember, I need to begin with something I know is true and end up concluding the inequality. It's going to look very much like rewriting this backwards. The last line here is something that I know is true. Every square is non-negative. So I'm going to take it as my starting point, and then hope that I can reverse all the steps and end up here. So let's begin with this, and let's write some explanation of what I'm doing. Since a square is always non-negative, I have this. And then the first few steps, expanding, adding, dividing, and contracting, those are all algebraic manipulations that are reversible, so I will simply write those without any commentary. Next, I want to take the square root of both sides to hopefully end up here. In order to take the square root of both sides, I need both sides to be non-negative, which luckily it is true. And now let's be very careful here. The square root doesn't cancel the square always. The square root of a square is not the thing we begin with, it's only the absolute value of what I begin with. The square root of the square is the absolute value. Can I get rid of the absolute value? Yes, because x and y are non-negative. And finally, I found a point where I use that x and y are non-negative. This is good. I knew this had to happen. And there we have it. I have proven the inequality. To conclude, here's a question you may be pondering. If I was supposed to begin with this, how did I come up with that idea? How, just by looking at this, I thought of beginning by writing this and doing these algebraic manipulations? That's a very fair question. And the answer is that, to be fair, we actually need to do this first, except that this is not a proof. This is what we sometimes call rough work. And rough work simply means taking what I want to prove and playing around with it to try to figure out where it came from. And once I figure out it came from here, I say, oh, this gives me an idea for a proof. I could begin with this that I think is true, hope all the steps reverse, and then I can end up with the thing I want to prove. And sometimes they will reverse, sometimes not, and then I have to think of something else. And only after doing the rough work, I would know to write this short proof. So to summarize, the statement of the theorem is not just an inequality, it tells me when the inequality is true. The proof begins with things that I am allowed to assume, things that I know are true. Every step follows logically from the previous one. Whenever necessary, I explain what I'm doing, and I end up concluding what I wanted to prove. And notice how the proof in one of the steps did notice the restriction we had to impose on the domain.